Hi, we're going to look at corrosion of metals. We have studied before that metals react with oxygen to form metal oxides. This reaction with oxygen, this is called a corrosion reaction. It occurs for most metals in the reactivity series except the unreactive ones like silver and gold. But the rate that it occurs depends on the position of the metals in the reactivity series. Now we are more concerned with corrosion of iron. Objects that are made of steel and iron undergo corrosion, and for these particular metals, steel is an alloy, so for these particular materials, corrosion is called rusting. And for rusting to take place, iron, which is also found in steel here, is going to react with oxygen and water present in air to form a reddish-brown solid called rust. And this reddish-brown solid, this is hydrated iron oxide. If we convert this word equation to a chemical equation, so iron is Fe, oxygen from air is O2, reacting with water, this will give hydrated iron-free oxide. Iron-free oxide is Fe. So iron is Fe, oxide is O, valency of iron is 3, valency of oxygen is 2. So you get Fe2O3. This is iron-free oxide. This is a hydrated salt, so you will have water crystallization with it. So it is Fe2O3 dot H2O. The dot H2O is the water of crystallization, and this is in the solid state. Okay, and this is what is rust. Now this equation is not balanced, so it has to be balanced. Now if you look at reactions, there's in general two types of reactions. There's oxidation reactions and reduction reactions. Oxidation means gain in oxygen, while reduction means loss in oxygen. And if you look at the rusting reaction, you can see that iron here has gained oxygen and has formed iron oxide. So, which means that rusting is an example of an oxidation reaction because there is gain in oxygen. But if you look at the iron as well, it changes from Fe to iron-free oxide. Iron-free oxide is iron with charge Fe3+, right? Because the valency of iron here is 3, so this is Fe3+. So it goes from Fe to Fe3+. So if it has gone from here to here, means that there has been a loss in free electrons. Because an atom here, this is an atom, this is neutral, and it has formed a positively charged substance, so it is a cation. How is a cation formed? A cation is formed by loss of electrons. So these are the electrons that have been lost. So oxidation of iron, you have the gain in oxygen and you have the loss in electrons. So this is rusting. Now for some metals like aluminium, corrosion is useful because when you have aluminium, it reacts with oxygen in air, it forms aluminium oxide, right? This is useful because the aluminium oxide acts as a protective barrier and it prevents aluminium from undergoing further reaction. However, in the case of rusting, this iron oxide, hydrated iron oxide, it flakes off and it cracks and exposes more surface of the iron to allow more rusting, which means that it causes further corrosion to happen, and it causes the metal to break down and weaken. Therefore, it's very important to prevent rusting from happening. There are several methods to prevent that, and as we're preventing rusting, the main idea is to prevent exposure to oxygen and water. These are the two factors that cause rusting. So, coating with anything that prevents these two from attacking the iron. So, coating with plastic, coating with paint, coating with grease, all these methods coat the iron with a layer that prevents water and oxygen from getting in contact. And this is called the barrier method. Another method is to use alloys instead of pure iron or steel. So alloys are stronger and resistant to corrosion. So chromium, nickel is added, so it forms stainless steel. Next, let's see sacrificial protection. The iron or the steel is protected by placing it in contact with a more reactive metal. These metals include zinc, magnesium, or aluminium. We use these metals because they are more reactive than iron. If you look at the reactivity series, so magnesium, aluminium, zinc are above iron in the reactivity series. These metals, we're not going to use them because they are too reactive. And these metals, when exposed to oxygen, they will be oxidized instead of the iron. So when we have oxidation of iron, we saw that Fe forms Fe3+, and it loses 3 electrons, right? So on this side, it means loss. When it's on this side, it means gain. So here there is loss of 3 electrons. But when you have zinc which is attached, the zinc will instead lose the electrons. So zinc is Zn2+. It's going to lose electrons. So here the zinc is going to lose electrons instead of the iron. So this is not going to happen in the presence of zinc because zinc is higher in the reactivity series and is more reactive. So this reaction will be favored. And in the presence of these electrons, the iron is not going to undergo oxidation. So it stays as it is. However, this metal is going to be eaten away. It will decrease in size. And because of this, when we do sacrificial protection, these blocks of metal, whether it is zinc, aluminium, or magnesium, these will corrode and have to be replaced regularly. So iron ships are protected from rusting by attaching blocks of zinc or magnesium to the ship hull, and these have to be regularly replaced. Another method is called galvanizing. Galvanizing means that the iron or the steel is coated with a thin layer of zinc. This acts as a barrier and at the same time offers sacrificial protection, because if you have, let's say this is the iron, and on top of that you have the layer of zinc, right? Now this acts as a barrier. Now let's say that it happens for some reason that the zinc is scratched. Even if the zinc is scratched and the iron is exposed, sacrificial protection still happens and the iron will not rust. So this is a very good method to prevent rusting. So with this, we finished 9.5. State the conditions required for rusting to take place. State common barrier methods: painting, greasing, coating with plastic. Describe how barrier methods work by preventing oxygen and water. Describe the use of zinc in galvanizing, both as a barrier method and sacrificial protection. explain sacrificial protection in terms of reactivity series, and electron loss.